Okay, in this video I'm going to demonstrate how to add and subtract, well, some addition and some subtraction of radical expressions, okay? So let's start with this first one, example 1. Now what you see here are basically two different radicals, the square root of 90 plus the square root of 160. And just like I say in class quite a bit, is difficult problems are simple problems stacked together. Okay, so what we're going to do is we're going to look at the 90 first, the square root of 90, then the square root of 160. So let's look at the square root of 90. A couple ways to do this one. I'm going to do this one a little bit faster though. I'm going to break square root of 90 down to the square root of 9 times the square root of 10. Now why did I choose that? I chose it because the square root of 9 is actually a perfect square root. And in the next step, you can just do the square root of 9, which is 3. And then 10 just stays the square root of 10. So we've got that one simplified. Now let's move on to the second part. Now the square root of 160. Well, I can see a perfect square in there is the square root of 16 times the square root of 10. Now I could have done 4 times 40, but then I would have had to break down the 40. So I'm going to take this, but this is 16 was the largest square root that I could find. So I'm going to get the square root of 16, which is 4, and then again radical 10 doesn't break down any further. Now look what happens on this step when I do that. I now have 3 radical 10 plus 4 radical 10. Remember to treat the radicals like they're variables, and you can just end up adding the two coefficients. And your answer is going to be 7 square root or radical 10. Okay, so there's your first one. Let's try example number 2 now, where there's some subtractions going on in there. Alright, so here we go. I'm going to do the same thing, same idea as I did before. I'm going to see if I can simplify each one of these individual radicals. Now 17 radical 5 is already 17 radical 5, and there's really nothing I can do with those because those are both prime numbers. So let's leave that one alone. Okay? Now, subtract 8. Now, the square root of 36, I already know that. That's 6. So it's 8 times 6. So that part's good and taken care of. Let's go to the next part. Minus 3, the square root of 80. Now again, think to yourself, are there any perfect squares in 80? Are there any perfect squares in 80, guys? There's a 4. 4 times what? Okay, so what else? So 4 times 20. 20 breaks down. There you go. So radical 16, or 3 square root of 16 times 5. And that's the biggest square root that you can find in 80. Okay, so now in this next line, I've got 17. That, by the way, that was the peanut gallery watching me do this. That's 17 radical 5 minus 48 minus 3 times 4 times radical 5. That just becomes 12. Again, let's just bring them all down. And you'll see on this step, you've got 2 of the radicals that are the same. So you can actually add or subtract the coefficients. And you get 17 radical 5 minus 12 radical 5, which is 5 radical 5 minus 48. And that's your final answer. Okay, I hope that helped.